everyone, what's up? Today we're going to be talking about the courses that I did in my fourth semester as a civil undergrad student, civil engineering undergrad student studying in India. If you haven't checked out the courses that I did in my third semester, I will add the link to that video in the description. So do make sure to check that out because I will be making a couple of references from that video. Also, I will add the timestamps to all of the courses that I did, so you will be able to skip around very easily. All right, so without wasting much time, let's just get into it. In my second year, second semester, or my fourth semester, I did a total of 7 courses. I dropped one of those courses midway because I was not very interested in pursuing that course for the semester. So I guess I did a total of 6 courses. 4 of them were compulsory disciplinary courses from civil. One of them was an option between economics and management, and I chose economics. And one was a humanity, and we'll talk about all of them right now. Also, I have my laptop here with me, like the last time, in which I've written down all the stuff that I want to make sure I don't miss out on. And yeah, let's just begin now. The first course that I'm going to talk about is analysis of structures. Analysis of structures is the continuation of mechanics of solids that I did in my third semester. Mechanics of solids mainly dealt with determinate structures, whereas analysis of structures mainly dealt with indeterminate structures. Determinate structures are the structures for which writing the force equations, that is sigma fx equals 0, sigma fi equals 0, sigma m equals 0. So those are the force equations, and writing those equations for the determinate structures is very straightforward because the number of variables is equal to the number of equations. However, for indeterminate structures, it's not that easy because the number of variables is more than the number of equations. And that's where we learn approximate methods of finding out the reactions. And that's mainly what we did in analysis structures. I'll give you an example of a determinate and an indeterminate structure. Say, for example, you have a cantilever beam. Cantilever beam is a beam which is fixed on one end and is free on the other. When I say fixed, I mean completely fixed. So writing the force equations for this beam is very simple. It's very straightforward. However, if I were to pin the free end of the cantilever beam, writing those equations would not be that straightforward because the number of variables would be more than the number of equations that you have. So that's where the approximate methods pitch in, and we use slow deflection method, we used moment distribution method, slope deflection equations, moment distribution method, and also talked about matrix methods where we use MATLAB to mainly deal with indeterminate structures. We also studied a little bit about two-hinged arches and kind of learned how to solve those problems. So I guess that was mainly what analysis of structures was all about. Yeah, I mean, it's a continuation of mechanics of solids, but it's definitely a little more complex than what mechanics of solids was like. But then again, it's always fun to have a challenging problem to solve. Yeah, all right. So the next course that I'm going to talk about is highway engineering. Again, very self-explanatory. We learn how to design highways and roadways. This course began with us talking about the material properties of a pavement, like materials of a pavement and their properties, like mainly bitumen is what we were talking about. Um, and then we shifted to talking about the geometric design of highways and roadways. So what that deals with is basically what should be the length of your road, what should be the width of your road, how many lanes should your roadway have. Um, if I have to design a horizontal curve on a roadway, what should be the radius and how should I design that curve so as to minimize the centrifugal force which will negatively act on the vehicles passing by. What should be the design speed limit for any given pavement, and questions like that. Also, like, say for example, I have to design a summit curve or I have to design a valley. I have to take into accordance the line of sight, and I have to design those curves in such a way so as to avoid accidents. So basically, that was what we were talking about in geometric design. We then also like talked about parking inventory systems. What is the most ideal design for any parking system? What angle should be designed for parking vehicles, so that we have maximum space utilization, and it's also drivers and convenient easy and convenient for the drivers to park and remove their vehicles from any parking. We also talked about traffic volume studies, where we were mainly talking about how would you measure traffic volume on any road at any given point of time. What is the speed of any vehicle that's passing on any road at any given time, and questions like that. And we also did mixed design in this course, like in materials. Only in highway engineering, the context was uh, bitumen and pavement, and not cement concrete. So I guess that was mainly what highway engineering was all about. We also had a lab component where we were mainly talking about the uh, material properties of bitumen, and we were just doing all those tests for ductility, elasticity, viscosity, and stuff like that. Highway engineering is a fun course. You will like it if you have ever been interested in any of the stuff that I just said. Um, so I guess, yeah, that's mainly what highway engineering is all about. Another thing that I forgot to tell is that if you do highway engineering, you're definitely going to get familiar with a lot of traffic rules. You're going to learn a lot of traffic signs, and you're going to be exposed to quite a lot of national standards for road design. Yeah, so yeah, now I'm done talking about highway engineering. Let's talk about soil mechanics. Soil mechanics, like fluid mechanics, is a very numerical oriented course where it's like you learn a topic, learn a you learn an idea, and you just apply it in numericals. Soil mechanics mainly dealt with the strength properties of soil, um, what is the water retention capacity of soil, how does the groundwater table affect the strength of soil, and questions like that. Also, how much will the settlement be on application of any load, and stuff like that. You will like this course if you have ever liked talking about settlement or stuff like that. We were also talking about the different types of soils, and soil exploration, that is, how would you excavate soil. There are quite a lot of soils out there. There are soils which swell in certain seasons. There are soils which have no water retention capacity. There are soils which are not cohesive, or there are soils which are cohesive. Then you have the issue of groundwater table and its height underground. And all of these parameters very majorly affect the strength of soil and the stress that soil undergoes. So what we were doing is we were just finding out the settlement, we were finding out the strength, the stress that soil undergoes under various different conditions, and that was basically what the numericals were all about. We also had a lab component for soil mechanics, which was very closely related to what was happening in the theory class, because soil mechanics is a course which has a lot of tests as a part of tests on soil as a part of its theory. So basically, what we were talking in the practical course was just just those tests that we had talked about in the class for theory. You will like this course if you like solving numericals. It's a nice course. It's a little challenging. It gets a little challenging when you're talking about the numerical side of the course. You will like this course. All right. So the next course that we're going to talk about is construction planning technology. Construction planning technology is like the ABC of construction and management. You are going to talk about the way in which bricks are laid in a wall, the different components of a wall, um, the types of doors, the types of windows, the plumbing material that is available in your house. How would you design stairs? How what are the types of flooring? What are the types of paints? What are the types of ceilings and questions like that? We were very heavily dealing with AutoCAD for this course, where we were like literally making a lot of floor plans every week um, in AutoCAD, and then we were using Revit, which is another software where we were rendering the floor plans into 3D models. And we were also using another software called Navisworks, where we were simulating the entire construction process of any given structure over time. So, construction planning technology was by far the most software dependent course that I have done in my entire second year, but it was fun. Towards the second half of the semester, we were talking about we kind of shifted from all of the stuff that I said before to non-tech. We started talking about the management techniques like PERT and CPM, where we were drawing a lot of flow charts and playing a lot with numbers, and also cost estimation, where we were estimating the quantity of soil that needs to be excavated for the foundation, how much money it is going to cost to do that, from excavation to paying the labor to materials cost and stuff like that. So it was kind of more management related in the second half of the semester, and the first half was where we were talking about all the minute details of any given structure. All right. So I guess that was mainly what we did in construction planning technology. You will majorly like this course because this is one course that is like very closely related to your surroundings. When you are talking about the kind of doors that are there, the kind of windows that are there, you can literally look around in your room and you will see stuff. So yeah, you will like this course if you have ever wanted to know what kind of doors and windows are available. How would you design stairs? If you have ever, you will like the management section if you've ever liked drawing flow charts and stuff like that. It's an overall good course. You will have fun in this course. All right. So those were the four compulsory courses that I did. I did one course in economics, where we were talking about microeconomics, and I did one course in public administration, which was a part of my humanity. In public administration, we talked about um, the structure of government, and we read quite a lot of the constitution, quite a lot of articles from the Constitution of India. Public administration is a course that you will like to do if you've ever been interested in reading the Constitution, and if you're aiming to become a civil servant or you're aspiring to write those exams. Yeah, so I guess those were the courses that I did in my second year, second semester, or my fourth semester as a civil engineering undergrad student studying in India. If you like the content of this video, do like the video, share it with your friends who might find it helpful, and subscribe to my channel. Um, if you stuck around till here, you're awesome. Thank you so much. Yeah, so I guess have fun, and I'll see you in the next one.